Let's start the new topic, that is couple. So what do you mean by couple? Couple means it is a pair of two. And here we are considering the pair of forces, that means two forces of equal magnitude and opposite directions which are not collinear so such kind of forces form a couple. And if you want to analyze that how does couple look, then I am giving you the figure. So in this figure, as you are clearly watching, that at point P or on the particle P, the force F1 is acting, and on the particle Q, the force F2 is working. So here first of all, you are governed to find out the position vectors first of all. So with the reference point O, the vector OP is the position vector of particle P, that means R1, and the vector OQ, that is the position vector R2. And these are related to the particles P and particle Q. The force which is acting on particle 1, that is F1, and here on the particle Q, the force which is acting is of F2. Also, F1 is equals to minus F2 because the force are having equal magnitude and having opposite direction. Now the angle theta, what you are observing over here, is the angle between R1 and F1, or we can say R2 and F2, but both the angles are same. So I can writing over here that theta is the angle between R1 vector and F1 vector. Also, if we consider that to find out the torque of the total system, and here the forces which are appear over here is known as couple of force. And therefore the vector tau is equals to tau 1 plus tau 2, that is equals to R1 vector cross F1 vector plus in the bracket R2 vector cross F2 vector. Now, as you know, the value of F2 is negative to that of value of F1. So I can modify this equation as R1 cross F1 plus R2 cross minus F1. And I can put this minus sign outside of the bracket, and hence R1 cross F1 minus R2 cross F1. So with this I can get the value of F1 as common, and inside the bracket the values which are including are R1 minus R2 cross F1. And as this is the vector product, so the vector product in terms of magnitude is written as mod R1 minus R2 into F1 into sine. Now which angle will be appeared over here? So you can see here is the vector R1 minus R2 and the affected angle to this particular vector quantity is phi minus theta because of this P, F1 and Q forms a triangle and so we have the value of theta in the two sides. So I can directly subtract the value of theta from pi. So here I will substitute sine into pi minus theta. And we know sine pi minus theta means here 0, pi by 2, pi, 3 pi by 2 and here 2 pi. So this is the first quadrant, this is the sine quadrant and pi minus. So this function will lie into the second quadrant and in second quadrant the sine function is positive and so the value of tau will be mod R1 minus R2 F1 sine theta. So this is the value where pi minus theta, what we have considered over here is the angle between R1 minus R2 and theta, and hence I can write down some statement. So here the statement I can write over here as mod R1 vector minus R2 vector sine theta, that is equals to perpendicular distance between the two forces. And if you want to find out the moment of couple, that is equals to F1 into the perpendicular distance between the two forces, because the momentum or the moment I can write in terms of force as the rate of change of momentum with respect to time, and here I can find out the momentum of couple by multiplying the magnitude of any one of the two forces and the perpendicular distance between the two forces, and such way you can obtain or generate the couple of force. And the best example of this couple is that when you are driving a scooter or car, to turn the vehicle, the force you apply on the steering, that is producing the couple. Now let us discuss the equilibrium of rigid body. In that, we shall consider the rigid body is under the influence of many external forces. Suppose these external forces acting on the body are F1 vector, F2 vector, up to so and so Fn vector, by considering that there are n number of particles in the rigid body, so each particle is experiencing this kind of forces. So the resultant force will be resultant means total force. We have to apply the vector sum to these individual forces, and therefore F is equals to F1 plus F2 plus so and so Fn. And we have to consider that this resultant external force is 0. Then the rigid body is said to be in translational equilibrium stage. So, now you consider the component forms of the force. Also, the component form of the force, that means Fx, but here the Fx for n particles, so I am generally writing it as sum over I Fx I. Also for y direction, sum over I Fyi, and for z direction, sum over I Fzi. So as the resultant force is 0, so the force in x direction, or we can say the resultant force in x direction is 0. The resultant force in y direction is also 0, and in similar way the resultant force acting on the z direction is 0. So now you assume one thing, that whenever this force is 0, then the torque is totally related to force, that means R cross F. So the resultant torque, that means tau 1 plus tau 2 plus so and so tau n, that is equals to 0. And with this we can say that the two characteristics of an equilibrium state of rigid body is that the resultant force is 0 and the resultant torque acting on the rigid body is also 0. Now suppose the rigid body is stationary and it will remain stationary if it is performing the rotational motion. So in normal case it is also stationary, as well as in the rotational motion the rigid body is also stationary. Then we can say that here the rotational motion is conducted under the influence of constant angular velocity, that means constant omega. So Now I can write down the equation for component form in terms of the torque as sum over I tau xi is equals to 0. Sum over I tau yi is also 0 and sum over I tau zi that is also equals to 0. Now we will solve one important illustration and then we will start the different aspects of this chapter.